Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into Design Amazon, one of the most classic and challenging system design interview questions. We'll build a global e-commerce platform from scratch, covering search, catalog, cart, checkout, payments, order management, and fulfillment. Whether you're preparing for a senior engineering interview at Amazon, Flipkart, Shopify, or any high-scale e-commerce company, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into one of the most famous system design interviews of all time, Design Amazon. We are going to build the architecture of a global e-commerce platform that handles hundreds of millions of products, hundreds of millions of active customers, peak traffic events like Prime Day, and end-to-end flows from search and catalog to cart, checkout, payments, order processing, fulfillment, and delivery tracking. If you are preparing for a senior system design interview at Amazon, Flipkart, Shopify, or any high-scale e-commerce company, this video is exactly what you need. Let's design Amazon from scratch. Here is the core problem. A customer opens the Amazon app, searches for a product, expects instant results, sees reviews, pricing, availability, and a buy box, adds to cart, checks out with a saved payment method, and expects the order to arrive tomorrow. But behind that simple click, massive complexity hides. Product catalog data is huge and constantly changing. Inventory must be accurate across thousands of warehouses. Prices and promotions fluctuate. Cart state must survive app kills and cross-device logins. Checkout must be fast, secure, and fraud-resistant. Payment must handle hundreds of payment methods and failure recovery. Orders must be split, routed, and fulfilled by the closest warehouse. Tracking must update in real time. At the same time, the system must support millions of concurrent users, third-party sellers, search indexing, recommendations, and personalized pricing. The design must be scalable, consistent where it matters, and resilient when anything fails. Let's define the functional requirements. First, product catalog and search. Users must search by keyword, filter by category, brand, price, and rating, and view detailed product pages with descriptions, images, reviews, and availability. Second, cart and wish list. Users can add, remove, and persist items across sessions and devices, with support for saved for later and price change notifications. Third, checkout and payments. A secure order placement flow that supports multiple addresses, payment methods, gift cards, promo codes, tax computation, and order confirmation. Fourth, order management and fulfillment. Order routing, warehouse allocation, packing, shipping, delivery tracking, and returns or cancellations. Fifth, user account and personalization. Account profiles, order history, recommendations, reviews, and customer service context. Sixth, seller and admin capabilities. Sellers list inventory, manage stock, set prices, and handle fulfillment. Admins monitor fraud, analytics, and platform health. These are the core building blocks. Now the non-functional requirements. Scale is the first concern. The catalog has hundreds of millions of products, and traffic peaks during holidays and sale events. Latency must be low. Search results and product pages should load in tens of milliseconds, and checkout should feel instant. Availability must be extremely high. Even a few minutes of downtime costs millions in revenue and trust. Consistency must be carefully balanced. Inventory and payment data must be strongly consistent to avoid overselling and double charging, while recommendation and search data can be eventually consistent. Durability and security are critical. Order history, payment records, and personal data must never be lost and must be encrypted and access controlled. The system must be fault-tolerant, with graceful degradation so that if recommendations fail, search still works. And finally, the system must be cost-efficient at global scale. Here is the high-level system architecture. The client layer includes mobile apps, web, and third-party seller portals, all backed by a content delivery network for static assets and edge caching. Traffic enters through an API gateway and load balancer, which handles authentication, rate limiting, and routing. The gateway fans out to microservices, search service, product catalog service, cart service, pricing and promotion service, order service, payment service, fulfillment and logistics service, and notification service. Each service owns its own data store, typically chosen for the workload. Elasticsearch for search, a relational database for orders and payments, a NoSQL store for catalog and cart, Redis for caching and session state, and a data warehouse for analytics. An event bus, often Kafka, connects services asynchronously. When an order is placed, inventory is decrement, payment is charged, a fulfillment job is created, and notifications are sent. Finally, a background pipeline runs search indexing, recommendation models, and fraud detection. The key metrics to memorize cold. Search latency, typically P50 under 50 milliseconds and P99 under 200 milliseconds. Product page load time driven by cache hit ratio. Checkout conversion rate, the percentage of carts that convert to orders. System availability, usually targeted at 99.99% or higher. Inventory accuracy, the percentage of items where the displayed stock matches actual warehouse stock. Order throughput, orders per second during peak events. Payment success rate, including retry and fallback conversions. Fulfillment on-time rate, the percentage of orders delivered by the promised date. And cache hit rate, which directly reduces database load and cost. These are the metrics interviewers expect you to discuss. Let's trace the end-to-end user journey. A customer opens the app and searches for noise-canceling headphones. The search service returns ranked results from Elasticsearch in milliseconds, enriched with pricing and availability. The customer taps a product, views images, reviews, and the buy box. The product page calls the catalog, pricing, inventory, and review services in parallel. The customer adds the item to the cart. The cart service stores the item and checks current availability, but does not yet reserve inventory. At checkout, the customer selects an address and payment method. The order service creates a pending order, calls the payment service to authorize funds, and then calls the inventory service to reserve stock. If payment succeeds and inventory is available, the order is confirmed. The fulfillment service picks the optimal warehouse, creates a shipment, and hands it to a delivery partner. The customer receives real-time tracking updates until the package arrives. Every step is observable, idempotent, and retriable. The core models and algorithms. The product model stores static attributes like title, description, images, and category, plus references to inventory, pricing, and reviews. The inventory model tracks available, reserved, and allocated stock per warehouse, and it must be updated atomically to prevent overselling. The cart model holds a list of items, quantities, saved later items, and applied promotions keyed by user. The order model captures order status, line items, shipping address, payment reference, and audit timestamps. The payment model records payment attempts, processor responses, settlement status, and refund history. The fulfillment model tracks warehouse assignments, shipments, carriers, tracking events, and delivery status. The search index uses inverted indexes, ranking signals, and personalization. The recommendation engine uses collaborative filtering and real-time behavior. The key trade-offs are consistency versus availability, and latency versus completeness, especially during high-traffic events. Now the low-level design deep dive. The API gateway routes requests to service clusters and handles caching, rate limiting, and authentication. Each microservice is independently deployable and scales horizontally behind a load balancer. The catalog service uses a document store with denormalized product data for fast reads and a separate relational store for canonical product attributes. The inventory service uses optimistic locking or conditional writes to prevent overselling. Hot SKUs are cached in Redis with periodic reconciliation. The cart service uses a key value store keyed by user ID, with a TTL for abandoned carts. The order service is backed by a relational database with strong transactional guarantees and an outbox pattern to publish order events reliably. The payment service uses a state machine with idempotent tokens so retries are safe. The fulfillment service consumes order events, runs warehouse selection based on proximity and stock, and updates shipment status through an event stream. The whole flow is orchestrated through durable messages with retry, dead letter queues, and observability. Key takeaways for your interview. First, always separate reads from writes. Use caches, read replicas, and search indexes for catalog reads, and use transactional stores for orders and payments. Second, design for idempotency everywhere. Payments, inventory reservations, and order creation must be safe to retry. Third, clearly explain where you need strong consistency versus eventual consistency. Inventory and payment are critical, recommendations and search rankings are not. Fourth, discuss graceful degradation. If the recommendation engine is slow, the product page should still load. Fifth, operationalize the design with monitoring, circuit breakers, rate limiting, and disaster recovery. If you can walk through the Amazon search, product page, cart, checkout, payment, and fulfillment flow with these 5 principles, you will demonstrate strong senior-level design thinking. That's it for Design Amazon. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on Design Amazon. We covered the full picture from search and catalog through cart, checkout, payment, order, and fulfillment, to the key models, low-level design, and interview trade-offs. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.